All right. Welcome to task 14, order of operations. This, you may remember the mnemonic device PEMDAS. Please excuse my dear Aunt Sally. We will be using that. There are reasons why it's helpful. There are pros and cons. But basically, there are also reasons against it, and we'll kind of go into it. But let's go to the next page, and I'll explain why. So the reason why PEMDAS can be problematic, and I'll kind of write it on the side here, is that when written like this, please excuse my dear Aunt Sally, this is usually how it's written. It's usually written upside down, where you have P for parentheses, E for exponents, M for multiplication, D for division, A for addition, and S for subtraction. The problem, really, for the reason why this is problematic is because multiplication and division should happen at the same time. Left to right. And addition and subtraction should happen at the same time. So writing it in this up and down manner really is not the way you want to do it. So if you really want to use this mnemonic device or rely on it, you really want to kind of rely on this, like this. So the P and then the E, and then MD at the same time, and AS at the same time. And you have to know that when you're doing these, the MD happen left to right, and the AS happen left to right. Okay, so let's get started, and I'll kind of show you what I mean and why that is and how it works. All right, so if we look at number 1, I kind of gave you an example of this. Okay, we just have a bunch of addition and subtraction. So we know from what I just said to you that addition and subtraction, it does not matter what comes first. You don't do addition first. You don't do subtraction second. You do addition and subtraction irregardless of the order. You just do it left to right. So given that that's true, we're going to do 4 minus 5. So if we do 4 minus 5, that means we do not have, basically you owe somebody money, because if I have $4, but you're taking 5 of it, you do not have enough money to give me. So you now owe me 1. So that would be a -1. And then I'm going to write the rest of the problem. Okay. So -1 plus 6. Okay, so now if I have -1 plus 6, so now if you want to, if you need to, think about where you are on a number line and how many hops you take. So if this is 0, sorry, that was really crooked. Okay, -1, 1, 2, 3, 4, 5. -2, -3. All right, so I was at 4. Okay, and then I hopped, -5. So 1, 2, 3, 4, 5. That's how I ended up at -1. Now I'm going to go +6, right? So now I go 1, 2, 3, 4, 5, 6. So now I'm at 5 minus 3 plus 2. So now I do the 5 minus 3. So this one you might not need to hop because you might be able to do it. If you have $5 and somebody takes 3 away from you, how many are you going to have? 1, 2, 3. I'm going to have $2 left, right? So 2 and 2 plus 2. 1, 2. I'm going to have $4. So I end up with 4. I didn't do only the addition, right? I didn't then only do the subtraction. I simply moved from left to right. Notice I only took the first step, okay? Whatever the leftmost step was, and I worked from left to right with my addition. Since it was only addition and subtraction, that's why I did it that way. All right, the same thing is going to happen in number 2. All right, the same thing is going to happen in number 2 because I only have multiplication and division. So when I only have multiplication and division, okay, I'm going to move from left to right. So left to right tells me I am going to do whatever's on the left first. So the left says 18 divided by 2. So again, you can use your multiplication chart. You can say, 2 times what equals 18, or 18, go up to the 2 row and you find what it equals. And in this case, it equals 9. Okay. And then what I'm going to do, I'm going to really start trying to work on showing my work correctly. And what I mean by that is you're only the piece that you highlight, you should get the answer for that. You should write the answer for that right below. And then everything else you should be writing underneath it as a step. So I'm not touching the times 4. That's coming straight down and I'm writing that right under it. The only thing I'm replacing here is, with the answer of 9. So 9 times 4, I would use my multiplication chart and I would get 36. All right, so now for number 3, this is where I need to start using, using this PEMDAS, if you will, and using those order of operations. What I see in this problem, I see parentheses, I see addition, and I see exponents if I'm kind of reading it from left to right. So from left to right, that's the order in which I see things. The first thing I see is a parenthesis, the next thing I see is an addition symbol, and then I see an exponent. So again, I see numbers in there, but if I'm just looking at operators, so my little number is an exponent, but that's also an operator. So what I want to do is parentheses comes first, meaning I want to do whatever's inside my parentheses if I can. So what I do is I look for what's inside my parentheses, and what's inside my parentheses is addition. So again, even though addition is my last step, addition and subtraction, that actually bumps first because it's inside my parentheses. So I'm actually going to do the 9 plus 2. And I'm going to get 11. Notice that's the only thing I change about my problem. Showing my work for this, I'm going to keep everything else the same. The only thing I change is what's inside my parentheses, the 9 plus 2. So that becomes 11. Now, I still have parentheses, but I can't do anything with it because I've already done it. I did the addition inside my parentheses. Now what I do is I do the exponent because that's what comes next. Really, if I wanted to write it like this, it would be the same thing. At that point, I could get rid of my parenthesis and it would no longer be there. So 11 to the third is really, from that last section, I know 11 times 11 times 11. Now that I could also fall under the multiplication section, and I would just move from left to right and do 11 times 11, and then that answer times 11. So 11 times 11 is 121. I know that from my multiplication chart, times 11. Now that's not a fun one, but I can still do it. So 121 times 11 is what? I get 1 times 1, 1 times 2 is 2, 1 times 1 is 1. Then I bring down a 0, get 1 times 1, 1 times 2, 1 times 1. I get 1, 3, 3, 1. So the answer to this problem is 1, 3, 3, 1. All right. On to the next one. I have division and I have addition. I always look first, before I do anything, I always look what I have. I read it from left to right. This is one of the instances where I read from left to right. I see what I have. Because again, I do have to decide, what do you have, or what do I have from that PEMDAS, because I do have to follow the order of operations. So what would I do first, division or addition? The D does come before the A. The division comes before the addition. So I'm going to do the division before the addition. So I'm just going to do the one step. So 30 divided by 3 gives me 10. I'm going to bring down the plus 6 because I only do one step at a time. And 10 plus 6 gives me 16. And I'm done. Now here, very, very similar. Notice how 4 and 5 are almost identical. But with the addition of those parentheses, it changes things up. Because with the addition of those parentheses, I now have to do the parentheses first, meaning I have to do what's inside the parentheses first. So when I rewrite this one, I have to rewrite 24 divided by, and now I do the 4 plus the 2. So 4 plus 2 is 6. I can drop the parentheses as soon as, I do the operation inside. So 24 divided by 6 is 4, and I'm all done. Now, it's interesting because parentheses, another word for parentheses is also grouping symbols. So we're going to see some more grouping symbols below, but another grouping symbol is also a fraction bar. So basically anything that can group or separate is a grouping symbol, or is considered a parenthesis, is considered in that parenthesis section. So like in number 6, there's actually 2 things that act as parentheses, not only the parentheses, but also the fraction bar. So I have parentheses, I have an exponent, I have subtraction, and I have addition. So I'm definitely going to start inside the parentheses. Inside the parentheses, I have a top and a bottom in that fraction bar. So I need to separate things, and I need to do the top and I need to do the bottom. So when I write this parenthesis, I'm going to put in that fraction bar, and I'm going to say to myself, okay, what's happening on the top? I have 9 minus 1. Well, what is 9 minus 1? It's 8. What's on the bottom? Addition. What is the addition? 3 plus 5. What is that? 8. And I have this exponent that has to stay. Okay, can I do that division? What is 8 divided by 8? It's 1. Okay, that exponent, how can I rewrite it? Well, that's really 1 times 1 times 1 times 1 times 1 from my exponent section last week. 1 raised to any power is simply 1, or 1 times 1 times 1 times 1 times 1 is 1, and I'm all done. Okay, so fraction bars are grouping symbols. They do separate, and you can work on the top and the bottom at the same time. but separately. Okay. Looking at this, we want to see that we have a lot of different grouping symbols going on here. We have the fraction bar, and we have two different kind of parentheses, or two different kind of grouping symbols of parentheses. We have brackets and we have parentheses. We always want to start on the innermost ones. So we want to start with the parentheses and not the brackets. So I am going to take care of this fraction bar. 21 divided by 7 is 3. Because remember, a fraction bar can be considered division. It also can be considered a grouping symbol. Because it's separate from everything, we can, do it. So 3, and then we're going to take care of this parentheses. 9 minus 5 is 4. Then we have this times 2, close the brackets, and we're squaring it. Okay, so now we have to work inside. 3 plus 4 times 2 is 8, right? And we have this bracket, and we have it squared. So now we have addition, and we have an exponent. So exponents come first. So 3 plus 64. Now, how did I get that 64? Well, 8 squared is really 8 times 8. Remember, it's not 8 times 2, it's 8 times 8. And 3 plus 64 is 67. All right, number 8 is very similar, but notice the exponents are in different places. So I'm going to leave everything on the outside alone. 15 plus, we have these brackets, 3 times. Now, I can't even do this subtraction on the inside. 8 minus, this exponent has to be taken care of first. 2 squared is 2 times 2, which is 4. And then minus 6, close my bracket. So what I had to take care of first was this. Now, what I have to take care of next is this. So when I do that, I get 15 plus 3 times 4 minus 6, close my bracket. Now I have to take care of that multiplication before the subtraction. So I get 15 plus 12 minus 6, close those brackets. And I get 15 plus 6, because 12 minus 6 is 6. And then I can add, and I get 21. All right, and then finally, the last one before the couple word problems. The square root of 144 is 12. And those are perfect squares. You can actually find them on the diagonal of your multiplication chart. So I'm going to pull that up for a second. So if you look, if you look, the square root of 144 will get you 12. Now, if we look at the bottom of this, 6 minus 1 times 3, we would need to do the multiplication first. So 1 times 3 gets you 3. So we have 6 minus 3. 6 minus 3 is 3. So we have 12 over 3. And 12 divided by 3 gets us 4. All right. Here. These yellow numbers on the diagonal here are your perfect square numbers. And what that means is that 2 times 2 will get you 4. 7 times 7 will get you 49. The one we just had, 12 times 12 will get you 144. So The square root of 144 will get you back to 12. The square root of 49 will get you 7. The square root of 4 will get you 2. On to the last page. For a rectangle, the formula perimeter equals 2L equals 2W is often used, where L equals the length and W equals the width. Use this formula to find the perimeter of a rectangle where 8 is 8 feet. Sorry, I'm butchering this. Use this formula to find the perimeter of a rectangle 8 feet long and 12 feet wide. So, we have, usually I like to draw a picture. Okay. We want to find the perimeter. We don't know what it is, but we do know that it's 8 feet long, and whatever it is down at the bottom, it is at the top, and it's 12 feet wide. Now, it's okay if your picture is not drawn to scale. They never are. I do like drawing a picture always, and we have a formula. P equals 2L plus 2W. I'm going to plug in. So I have P equals 2 times 8 plus 2 times 12. Where did I get those? Well, I had here and here, also from my picture. P will equal 16 plus 24. P equals 40. And you can say the perimeter is 40 feet. All right. Write out the mathematical expression that would calculate the answer to each question. A family of 4 goes out to a buffet and pays $14 each for food, $3 each for drinks. How much do they pay altogether? So, four people pay for food and 4 people pay for drinks. Now, because they're saying mathematical expression, no equal sign. Equation, equal sign. Okay, just something for you to be aware of. Expression, they will say evaluate. Equation, they will tell you to solve. So if you notice the directions for this worksheet was evaluate, whereas when you get to algebra, the directions will say solve. So 4 times 14 plus 4 times 3. 4 times 14 is 56. 4 times 3 get you 12. When you add them together, you get 68. All right. It costs $68. Don bought a car for $800, spent $500 on repairs, and sold it for $2,500. How much profit did he make? So, he bought for $800 and paid $500 on repairs. So that's going to cost him $13. So this is he spent. He made $2,500. Okay, so $2,500 minus the $1,300 he spent will be profit. So he made $1,200. All right, let me know if you need any help, and try some on your own.